Hello, 6th grade. Today we are working on probability of compound experiments. So down below you can see that there is a table for us to use. It says cube 1, so that's dice. This is the first one. And this is the other cube right there. Right? So we're going to roll 2 dice at the same time. So something that we could roll would be a 1 and a 1, or we could roll a 1 and a 2, or we could roll a 1 and a 3, or a 1 and a 4, or a 1 and a 5, or a 1 and a 6. Okay, so let's back up here, and I want you to see that this 1 is this 1. The first dice could be 1, and then the second dice could be 1, or the second dice could be 2, or the second dice could be 3. In all of these cases, the first dice always is a 1. There's a 1 and a 4, and a 1 and a 5, right? So hopefully you can see where all of that is coming from. Okay, so let's look at the next row. I see that there's a 2, so I'm going to write 2 first. This says that on this roll, instead of getting a 1, we got a 2 with this dice. And then with the other dice, we got a 1, and then we got a 2, and then we got a 3, and then we got a 4, and then we got a 5, and then we rolled a 6. I'll put a comma in between here so you can see it again. Right. So again, that's not 21, 22, 23, 24, 25, and 26, right? That's first a 2, then a 1. So if we follow this pattern across, we can see that going down is going to be a whole bunch of 1s. Going down in this column is going to be a whole bunch of 2s. The next one is going to be 3s. The one after that is 4s. Then 5s, and following the last 6s. All right, so that's just 1 dice. Now let's look across at our patterns. So remember how there was a 1 on top? Then every single one of these started with 1? Well, let's look at the next row. In front, there's a 3. That means every single one of these is going to start with a 3, comma, 3, comma, 3, comma, 3, comma, 3, comma, 3, comma, right? Then the next row starts with a 4. So the first dice ends in, or lands on 4. 4, comma 1, 4, comma 2, 4, 4. I think you're catching on to the pattern by now. That means the next one should be 5, comma, 5, 5, 5, 5, 5, and then the last one, we'll use pink, 6, comma 1, 6, comma 2, 6, comma 3, 6, comma 4, 6, comma 5, 6, comma 6. All right, these are all the possible outcomes. I don't know if it'll let me just get the blue because I wrote the blue first. Oh, it is. All right. Make this a little bit smaller then. Get the blue, get the blue, get the blue. Okay. So, where are all of the possible outcomes? We have to include all of them inside this big red rectangle because all of those have 2 outcomes. So I can see that it's 1, 2, 3, 4, 5, 6 tall, and it's 1, 2, 3, 4, 5, 6 wide. That means for all the possible outcomes, 6 times 6 is 36. 36 outcomes. You can count all of them inside the red. It will be 36. And if 36 is all the possible outcomes, then for the next couple of problems, when it is asking about a fraction, if 36 is all the possible outcomes, then 36 has to be the bottom of the fraction. All right, so now if I keep reading, it says, what is the probability that you will roll doubles, which is 2 of the same number? So let's see, here's a 1 and a 1. Here's a 2 and a 2. Here's a 3. Oh, no, 3 is not the same as 2. So I'm looking for the same number twice. Yeah, cool, a little diagonal line. Looks like there are 6. 6 out of 36. And if you want extra credit on your quiz tomorrow, you can simplify this by dividing both of them by 6. Divide by 6. Divide by 6. Gets us to 1/6. This is the fraction. If we rolled 6 times, we would expect that one of those times we would get doubles. Okay, let's get rid of this now. Okay. Get rid of the highlighting so it doesn't distract me on the next one. Okay. Next one says as a percent, but I'm going to start with the fraction. And again, there's 36 outcomes. What is the probability that you will roll a sum of exactly 7? So our example is 2 plus 5. So let's find in our grid 2 and 5. Here's 2 and 5. Put in orange for you. But here's also 2 and 5. The order is reversed, but 5 plus 2 is 7. So let's think about another way to make 7. We could say 1 plus 6. So I'm looking for boxes where there's a 1 and a 6. Here's one. Oh, here's one. Okay. Let's see, another way to make 7. Let's see, we used 1, we used 2. Let's use 3. 3 plus 4 equals 7. So I'm looking for a 3 and a 4. There's a 4 and a 3. That's 7. A 3 and a 4. That's 7. I think that's it. Hey, do you see that it's diagonal again? Right. So that's kind of cool. Let's look and see if there's a pattern here diagonally. I'm going to do kind of this green one here. As we go across, it looks like these numbers add up to 6. 1 plus 5 is 6. 2 plus 4 is 6. 3 plus 3. And if you look at this one, they add up to 8. 6 plus 2, 5 plus 3, 4 plus 4. Let's try another one. This is the 9 sum. All those numbers add up to 9. This one is 5. That is a really cool pattern. Here's the 4s. These numbers here, 6 plus 4, 5 plus 5, these add up to 10. Let's see. These 2 will add up to 3. These 2 will add up to 11, which means our very last ones here, this one adds up to 2, and this one adds up to 12. Really stinking cool. All right. I got a little carried away there. Let's go back and look. How many of these outcomes add up to 7? And that was our original orange ones. So now I'm going to count them up. There's 1, 2, 3, 4, 5, 6. Hey, that's the same as what we just had. So this is 636. So I'm going to change that to a percent. Grab my handy dandy calculator. So we have 6 divided by 36. Ooh, times 100. 16, and then all 6s after that, equals 16 and 6/10. I'll put this in a different color, percent. All right, some pretty neat patterns are happening inside of this table. Don't forget to turn your work in now that you're done.